Hello everyone. Today let's go over a medium question that I just solved about 5 minutes ago. This one is called sum of subarray ranges, and it's pretty simple, and I'm going to show you a very intuitive way to do it. And it's not going to require anything fancy. It's not going to require even an O of n time complexity solution. And so simply you're given an integer array and you want to find the biggest and the smallest element in each subarray of this input array, and you want to add all of those together and then return that result. So if you know what a sorted list in Python is, this becomes very, very easy because we can simply the sorted list will keep track of the minimum and maximum element in O of one time so that we don't have to, so we don't get time limit exceeded. For example, the way I did it before was just to get every single subarray, right? Starting with I, length of nums, and then let's call this subarray equals nums of I to j plus 1 because j is inclusive, and the way Python works is this list splicing does not include this other index, so we plus 1 to offset that. And then now we're just going to ask, and we're going to add the maximum of the subarray minus the minimum of the subarray, and we're going to return results. This is fine, but as you can see, that is very inefficient because this by itself takes another O of n time complexity, because now we have to find the maximum of the subarray and the minimum of the subarray, which is definitely not the most efficient way, and you will get time limit exceeded. Now let me show you the way that I discovered that I think is a lot easier. So instead of finding the minimum and the maximum every single turn, let's just define a sorted list called current. And then let's iterate over the array once. And then every single time, because the subarray starts exactly when this second loop starts. So for example, we have 1 here, and then here we're adding 2. And then we're going to add from 2, we're going to add 3. Right? So 1, 2, 1, 2, 3. 2 and 2, 3. That's each subarray. So we're going from left to right and expanding all the way until we can't expand. So we're essentially adding an element on top of the current ith element, which is the line 5 loop. And then here we can just simply add nums of j because nums of I is already inside of current, which we're going to add it here, right? And then now we can simply add the last element and the beginning element because we know that this is already in sorted order. So this is just O of one time. You're calling the last and the first element. And then we can return result at the end. And as you can see, this is much more efficient because of this magic that the sorted list does in Python. And there you go. So it passes all the test cases and it doesn't get time limit exceeded, which is great. So I'm going to explain what we're doing here. We're simply adding 1, and then we're clearing 1. Because 1 is by itself, we know that 1 minus 1 is 0. So anything plus 0 is not including anything else, right? When we get to this line 9 loop, we're going to add 2. And then we're going to add the biggest minus the smallest, which is going to be 2 minus 2 in this case, or 2 minus 1 in this case. And so 2 minus 2 comes first, and then 3 minus 3 comes first. And then after that, we're going to go back. So I placed at this index, and then I goes at this index, and j starts at I, and that's the main thing. That's how you get all the subarrays. And so this time, we're going to do 2 minus 1 because I was 1, right? And then we're going to do 3 minus 2. And then we're going to do 3 minus 1. And then we get 2, right? So if you print out what current is, it should make it a lot easier. You can see 1, as we said. So you can think of it as like a sliding window going right, then 1, 2, then 1, 2, 3, and then 2, and then 2, 3, and then 3. So, yeah, just shows you, again, this is a very, very powerful technique in Python. And I hope this is helpful, and you can exploit it to any kind of scenario where you want to find the minimum and the maximum element of a subarray without using heaps, because heaps make the implementation more complex in my opinion. So that's it for today. Thank you for watching. I hope this is helpful, and stay tuned for more. Thank you.